Hello and welcome back to another video. In this one, we'll be learning about Laplace transform, or the basic rules for Laplace transform. So, we use Laplace to transform a function from the time domain denoted by t. So, we have the time domain function, and we need to make it, we transform it into a more complex domain. We call it the frequency domain denoted by s. So, we have a set of rules that we use to make a time domain function a frequency domain function denoted by s. So we'll be touching upon them now. So we have the first rule: the Laplace of a constant is the constant divided by s. So the Laplace of -3 is -3 divided by s. The second rule is the Laplace of exponential at, a being any other constant. If we take the Laplace for exponential at, we get 1 divided by s minus a. For example, if we have the Laplace of exponential -2a or 2t, sorry, we have 1 divided by s minus -2, and therefore we have 1 divided by s plus 2, because a negative and a negative is a positive. So the third rule is the Laplace of t to the power of n. So we have t to the power of n, as long as n is bigger than or equal to 1. So the Laplace for t to the power of n is n factorial divided by s to the power of n plus 1. And we have, let's take the Laplace of s to the power of 3. So we have 3 factorial divided by s to the power of 3 plus 1, which is 3 factorial divided by s to the power of 4. That's the third rule of Laplace transforms. We have the fourth, which is the Laplace of sine at. Laplace of sine at, which is a divided by s squared plus a squared. So the Laplace of sine t is 1 divided by s squared plus 1. The fifth rule is the cosine of at. Cosine at. So if we take the cosine of the Laplace cosine of at, we have s divided by s squared plus a squared. So if we have the Laplace of cosine t is s divided by s squared plus 1. Now we have the values, or the Laplace transforms, for sinh and cosh. So we have sinh, yeah, and cosh there, and it's exactly the same transformation, except is a for the sinh is a divided by s squared minus a squared, which is gives us, if we have take the Laplace of sinh t equals to 1 divided by s squared minus 1. And if we have the Laplace of cosh at equals to s divided by s squared minus a squared, and if we take the Laplace of cosh t is s divided by s squared minus 1. That's all the basic transformation rules for Laplace. Now we have conditional transformations. The first one is expanding or shifting property. If we have the Laplace of exponential at multiplied by any other function, for example sine of at, we have the answer of a divided by s minus a to the power of 2 plus a squared. So if we have the Laplace of exponential t multiplied by sine t, we get 1 divided by s minus 1 squared plus 1. So if we have a exponential multiplied by a function, it's a shifting property. So we replace the value of s with the denominator, with the value of the denominator of the exponential. So if we have exponential t, then it equals 1 divided by s minus 1, and that's the value of every s in the other transformation. The second one is the derivative property. So if we take the so 2 is derivative, if we get t, the Laplace of t multiplied by sine at, we take this part, so we have the sine is a divided by s squared plus a squared. All we have to do is derive this fraction by how many times or how many power of t. So if we have t squared, then we have to derive this fraction twice. If we only have t, then we only derive this fraction once. And that's all the conditions and rules for Laplace transform. Thank you for watching. Like if you enjoyed, don't forget to subscribe and share if it's helpful. Thank you.